4 was released in this spring. We closed 100,700 issue. It's quite stable from that perspective. There was really a lot of things. I don't remember exactly. You have the load on the website. We improve refactoring. We have a 6 megabyte deployment image. We have a massive cleanup of tools. There is a long list. This is boring. So what we have, for example, that is visible, we have a dark theme, which is much nicer, because people like that. For me, I use the white one. But the dark one is cool too. So more important, we have the GT tool. And I don't know if you saw the presentation yesterday, but the idea is that we have a brand new inspector and a brand new way to find information. I will show you, I have a video that describes the idea. So the idea of the inspector, the idea this is to make a focus on objects. So we manipulate objects all the time. So what you can do is that for your object, you can define the panes and how you want to interact and what are the views that you want to have on your object. I just want to show you an idea of that. Typically, this is Marcus did that. So here, for the people that are working with the compiler, they get a compile method. And before, what you would see the byte sequence. That's it. And now they have all these panes there, so they can see the source code, the abstract syntax tree, so they can navigate in the abstract syntax tree graphically. They can look at the decompiled code, look at the byte code, look at the IR representation, because when you compile to the intermediate representation, and then you optimize this intermediate representation. And when you click on one of the panes, you can jump into the other representation. So what is very interesting is that Marcus is not a guy that is doing user interface. When the inspector get out, he was so excited that he did that. It was for me, this is the first time that I see him doing user interface. So he said, oh yes, and if I click here, I see this information here. Yes, because before they were doing that by hand, like, okay, take this guy, inspect, So now they do it when you click and select the other one and things like that. So for them, this is really a productivity tool. And this means that every object, every domain object that you define, and Alex has the same for his visualization. So I guess that when you have a RASAL object, then you see the visualization. So you have this a modular inspector with the view on the object you manipulate. And then you have a spotter. So spotter, this is an omnipresent way to find information in the system. And what you will do, you will press a key, boom, you get this stuff, you type, and then you jump to the place. And it can be packages, class, pragma, menu, and objects that are there. And this is really nice. There is a nice presentation. Dogo did a presentation into a conference, and this is nice because he was comparing the user experience in Eclipse at the end of the talk and the user experience with Spotter. And this is nice to see that in Eclipse they have at least 4 different ones, while in Spotter you have one that unifies everything. Okay, so I want to show you that normally. Why doesn't it start? we've got a lot of fun with that. It's a bit fast and it moves a lot, you know. But they are very great fun to do that. What they try to convey is this idea that your object, they have multiple forms, and that you want to see the object via the form that they fit better for you. So for example, Stephane from Beta 9, he has a special inspector to check the request on his server, so that he can inspect a stream of requests from the source and navigate into the answer of the header of the main type of all these kinds of things, so he can navigate into the structure interactively. So okay, so after we work on first-class variables, and Marcus will present that Friday or today, I don't know which talk he will switch. The point there, this is, so we call them slot. Why variables in our wonderful world are not first-class objects? That's the point. So, and what I mean by that, and of course we don't want to have a loss of performance. So, why we don't have a meta object, like we have the class, the compile methods where we can interact with it. So we want to have variables that are first class. And for example, and this is what we call slot. So with slot, what you will define, you will not define your class as it has instance variable, which is a bunch of strings, but it has real first class variables. And one example is that, imagine that you have several booleans. Maybe you can decide, oh, you know, please, dear compiler, can you take all those wonderful booleans and map them into a byte and generate for me all the bit and trickery so that I can access? Because conceptually, for me, I don't want to know that the compiler is optimizing that in my back. What I want just that pay attention that I give enough information so that it can do the right optimization. Or I want an active value. So I don't know if you know what is active value, but in a Lisp-ish world, this is something where you set a value, you have a reaction. Why do I have always to code that stuff in all the applications that I do? So I want to have a library that says, oh no, this instance variable is an active value, it will raise an event when it is set. So the day where the slot were for real into Pharo, because slot were, there is a paper from the University of Bern on slot, on DID, and in fact there is nothing that new there. You know, a common list, Silos has that since 1990. So maybe this is the time that we get the right ideas back to Smalltalk. So the idea is that the day where we could really compile slot and things like that, one guy in the company took that and said, oh, I implemented the relationship. Because I want to have a relationship in my system, so like that, I can generate some of the code, and I don't want to have to code all the time the same navigation code that we all code. And this is the vision behind first-class variable. And then we have also first-class globals. So this means that now a global is not just a binding somewhere into a dictionary lost. This is a real object. We can grab it and we can start to do things with that. What we discovered, and that's a parenthesis that I opened, is that what I expect is that in the future we will identify caches. Guillermo Polito, in his PhD, he can bootstrap Pharo. He can bootstrap Pharo tree from files and get the kernel. But to do that, he had to infer the relationship between class var, how they were initialized, what are the global variables, how they are created, and sometimes what he discovered is that we have something like 40 different ways to do cache. Because everybody is implementing his own. Oh yes, I want this cache because yes, I use a lazy initializer for doing that and things like that. So our belief is that if we have a first-class object that represents variable, then we should be able to attach to this variable a cache behavior. You can say, oh yes, there are 5 different cache approach. Let's use, okay, which one do I want? I want this one, and we don't have to duplicate all this logic everywhere. So that's a parenthesis. So we will get there. So what we can also do is that we want to be able that people can build tools much more easily and say, I want to know everywhere in my system when I have a read or a write on this variable. And this means that from the tooling point of view, it will be far easier to do that. And of course, we don't want to have an impact on the execution. So what's happened is that they take advantage that we have an open compiler. So this means that you have a special bytecode. You can define how how you generate the bytecode for your specific slot. So this means that like that we don't have, oh yeah, this is cool, but this is slow. So that's, normally this is in FharoPro, and you have all kinds of things. If you really want, you should check on the website. Now we decided that we want to have maximum 5 or 7 points that we say that are new, and all the rest, it is current normal activity. So I just want to show you what we are doing. So we are working on a much better database support. So there is a project that is called Garage that provides a unified API for all the relational database driver. This is an ongoing effort. We will work on having Glomp up to date because it's not the case. We will continue to work on advanced reflection. So what we want to have object-centric debugger, and we will get there. So object-centric debugger, it is stop when you arrive to this object and not another one, or stop when this object changes state. And for people like Alex that are doing visualization with a lot of nodes and you want to stop on these nodes here and not all the other one, this is really important. So we are working on replacing the change format, because the change format, it was nice, it feels old and old. So what we want, we have something that can log refactorings. You can say, oh, I did all these refactorings, or can I replay the refactorings, or can I replay the change made with the refactorings with a nice undo system. So this is the PhD of Martin, and he worked a lot on that. And then we have a real change tool where we can see, the idea is that we want this to be the support for code review. So this means that I write code and I want you to give me feedback on my code. So can we do these kinds of things? What is the model? Can we manipulate the change that we do as much better object? Of course, Max, I don't know if Max is here, but not the other Max, SQL. So there are people that are working on the Git integration. So this is important from that perspective, but we don't want to expose everybody to Git craziness. So we are making, it will take time so that we arrive to something that as a normal user, you can continue to work a nice way, and then if you want to be a powerful user, you can go inside and do the Git magic invocation. So something that is really exciting, this is Spur. So Elliot presented that at ESUG last year. Squeak is shipped with Spur. Pharo is not shipped with that because we have a stabilization phase. Why? Because we use more feature than Squeak from that perspective, especially weeks arrays and things like that. So we have a version of Spur that is working for Pharo, but this is not ready for to be shipped. So normally what we will do is that we will have a special release for Pharo 4 and Pharo 5. So what is it? In fact, this is a new garbage collector that is going 10 times faster, approximately, from what I understood. It is a new object format, so when you program in Smalltalk, you have a structure that represents the object, and on this structure you have all kinds of information that is encoded, and Spur proposes a completely different new way to encode information so that it is faster. There is support for ephemerons. So ephemerons are special kinds of weak structure that you find in JavaScript, Haskell, and VisualWorks. So maybe I don't know in Justin if you have support for FML. Kind of, a little bit. So the idea is that those are structures that mutate when this is a pair and it's strong and weak, and when the weak is garbage collected, the strong become weak and things like that. So the point is that you can handle recursive and cyclic dependencies in a much better way. There is support for pin objects, so this is that when you do an FFI call, for example, you don't want that your object is garbage collected or move between the old space and the new space and the old space and things like that, so you can say, no, please, you don't move. There is also support for fast become, so the idea is that you don't have to do a full scan of the heap to switch pointers and things like that. So what we see is that on normal application, it should be about to double the performance. So that's we really want that stuff. So we are working with Elliot because this is very important for us. So Stephane is really fully working on it. We were planning to release it for SU, but it's taking a bit more time because SU is too soon. Okay. So from that perspective, if we look at the future, what will happen in the future? We will get Spur, we will get OS window. So what is OS window? OS window, this is right now the virtual machine is controlling the event that you get. And what we want that the virtual machine does not do anything, and that we at the image level can manage our life and get access to native window and native event. So OS window, from that perspective, this is the API, and behind the scene we have SDL plugin. So SDL, this is a simple, I don't remember, layer that is used in the game industry. The next thing that we will work, and this is probably for Pharo 6, this is block. So this is a completely new graphical kernel. And on top of block, we have brick, that is a complete new widget set. Because we want to have a widget set that is in competition with what you can find in Java today. We cannot continue to work with these widgets that look like the 80s. So I will show you a bit. And then we will have 64-bit and 3D FFI. That's important for communication. So the status for the 64-bit is that Spur, by definition, is working in 32 bits, but this has been designed by Elliot to work in 64 bits. So this is in development, and when Spur is released for Pharo, we will work on the 64-bit port of the plugins. There is also in the pipe, there is Sista, so Clément presented that at ESUG. So this means that you can watch the YouTube video if you want to know more. So if you look at the JIT technology right now, you have 4 levels of optimization. You have the cache, the polymorphic inline cache. Then after you have something that basically, conceptually, you execute a method and say, oh, it looks cool, it has a nice property. I will generate assembly instead of executing the bytecode. And then you have the 4th level that is, okay, this execution with different stack element is interesting. Let's inline do a constant folding, remove blocks, do all kinds of crazy optimization, and generate assembly code. And Sista is about that, and this is what you have, this kind of technology, this is what you have in V8 and all the real modern Java virtual machine. And Clément is working with Elliot on that, but to do it at the image level, because you go much faster. And the cool stuff is that when you save the image, you can save the optimization. You don't save the assembly because you don't know on which platform you will restart, but you can save the optimization. So the idea is that, for example, on Amazon services, you could get a really much faster startup, and this is one of the ideas behind that. And they expect that we will have maybe a factor 150 of speed up on top of Spur. So we will see that. And they hope to have that ready for mid-2016. So OS, I was mentioning that. And then I wanted to show you why this is not moving. It is moving? Oh, it is moving. On my machine. So this is not in production yet. This is a prototype that I want to show you. This is how we manage touch events. And you can program them. We have something like 8 default events. So why do we see this little red stuff? This is because Thales asked us. Thales told us we want a demo where you can show the movement, the gesture, and you can see where the fingers are on the screen. So normally you don't show that. And this is a little project that PR1 did with Jean-Baptiste. Yes. And the idea is that, for example, for Thales' prototyping systems, and I really wanted to know, okay, can we get all the gesture so that we can really build a new generation user interface system? So that will come probably, it will come with block together. You can use that already, but you have to use that into a separate native window. But you can start Pharo headless, and if you start Pharo headless and create a new window, you will have a native window where you can start to display that. Clément if you are interested, Clément started to play with a little Bomberman, so where you have sprites that you can drive into a forest and shoot other people. So, and it's a Bomberman, no? So, and this is really using this, and this is a nice example. He developed that in 6 hours. So what is block? So this is that I will present that Friday. This is the last talk of the conference. Don't miss it, which is cool. Yes. So people like that cannot say that I'm doing only the good part of the conference. Huh? So the idea is we completely rewrite the lowest part of Morphic. And on top of that, I will explain that next Friday. On top of that, I just wanted to show you what the people of there are doing. So they started to re-implement Spotter on top of block, and since there is no widget, they are re-implementing the widget themselves. So here this is a list that contains 1,000 elements. And what is interesting in this list is that the size is not the same for each element. It's a text, it's a full text. So this is the new text model because we have a new text model inside Pharo. You can do in place edit. Because why do we have to say click? I want to click and rename this category. This is a concept from the past. I want to click and edit it in place. And this kind of list, and then you can shrink wrap the stuff. And we don't want to have lags and things like that. So this is the work of where is Alex. So he's just outside as a student volunteer. And there is the other example that display the icons, but for them, this is a test of speed because they have to read the binary of the icon. So he explained me that yesterday. He told me that normally this is difficult. This is difficult to do these kinds of things really fast because the icon they have to be processed on the fly, or I don't know the detail. So I just want to show you some fun external project. I never met the guy, but I want to show you that. This is This is a particle aerodynamic system completely written in Pharo. And you see, so you have the wind, and then that explains why a flight can be on top of the wind. You have this one. This is the same. So here he has used the particle to represent water molecules, and then he's mixing 3D. So this means that you have this particle on top of the screen, and then you have the ball that is a 3D element that gets inside. And for him, that was how can I mix my particle system with the 3D things? And I saw it with Spur. This is a way to simulation, apparently. What you should understand is that all those guys are little molecules, and I think that the border is also a special kind of molecules that are the border between the two worlds. I don't know how this is computed. So the project is called, and yes, and now we can take some particles and make some mess. What is interesting, the first time I saw that, I said, oh, he's calling a library. No, this is completely written in Pharo. I saw it on Spur, and this is really much faster, so that's really interesting as a real benchmark for real stuff. Just to finish, there is this guy that is doing wooden. So this is a complete 3D. So his goal is to do a game platform with a Pharo, and you can. So what you see is on the GPU. So this means that all the 3D is on the GPU, but you can manipulate live the parameter of the shader script on the GPU, and that's quite nice. So Ronnie is working on that, and for that he has something that is called virtual GPU, where you can really attack the GPU and send the programs there. So, yes, there are a lot more, but I will stop. Okay. So if you have any question, we have 5 minutes of questions. You can try it right now. This is not a problem. No,
because you want to use atoms. You cannot use atoms. I will explain why you cannot use it right now in the afternoon.
Yeah, but we are working on that.
Anyone not using anything that is related can use Spur and Spring.
So just that you know, because Native Boost is generating assembly, and this is based on the old format. So this means that we have to migrate that. Okay. So, good coffee break, gentlemen.